we're going to be talking a little bit about kind of outdoor Wi-Fi, specifically some best practices in terms of mounting the APs. So just quickly, a little bit about me. I'm Jack. Been with Seven Signal now for I think about 3.5 years at this point. Been doing networking, kind of route switch firewall stuff for over a decade now. Wireless has always been kind of mixed in with that. And I guess the past 5 years or so, I've been focused primarily on Wi-Fi. So we'll kind of dig into everything here. With outdoor Wi-Fi, there are some very unique design challenges that you don't have kind of necessarily in the office deployment or warehouse deployment, kind of that mixed kind of environment where you're indoors. We'll talk a little bit briefly about some unique challenges, and then as well as kind of some different types of specifically wireless networks, not necessarily Wi-Fi specific, but just wireless, whether that's a point-to-point, point-to-multipoint, mesh, kind of those different types of network designs, whether or not they meet your requirements. And then as well, we'll talk a little bit about some common issues that are unique to outdoor Wi-Fi, and then kind of bringing it all together with kind of best practices for actually deploying the APs themselves. And then, as always, we'll end with a Q&A. So if you guys have some questions, just put them in the Q&A box within Zoom, and then we'll get to those at the end here as well. So like I said, some of those design challenges that are very unique to outdoor Wi-Fi in particular. The main one being you do not have walls, you do not have doors, you don't have those attenuation sources that you can design around that you know will limit or shrink your coverage cell. You can't plan for that. There's a lot of free space outdoors, so your signal is traveling further than it would be indoors with walls. Um, so that signal is propagating outside that kind of designed or ideal coverage cell for your end users or your clients. So you have a lot of bleed over. You have clients associating to APs that are not always optimal. Those kind of things. The other big thing is security. Since it's outdoors, a lot of the times it can be very hard to um, limit physical access to the coverage area. So when you're indoors, you can just, you can lock a door. You can prevent access to specific locations. Um, Typically, APs are mounted on the ceiling, so getting access to the access points can be kind of a challenge. Outdoors, they're not always people are not always there, so you can, you have free reign basically to get access to your equipment. So there are some things that are a little unique with that. Attackers don't have to actually be physically near your network to um, try to either cause disruption and do like a deauth attack, or even try to brute force their way onto the network. They can be blocks away. They could be even further than that as well. The other thing too is at most of these outdoor rated access points, to get them to join your controller, a lot of them use MAC registration. So they'll use the MAC address of the device itself, and uh, as I think most of us are very aware, it's trivial to just spoof a MAC address these days. So you can unplug the device if you have access to it, and then plug in your own device, and then cause issues depending on how the network is set up, that kind of thing. The other thing too is with mesh networks in particular. So the more hops you have to get back to the network, you are increasing latency, and by doing so, you're also lowering the client bandwidth. So, at a very simple term, uh, Wi-Fi it's still a half duplex mode of communication, and very simply, only one device at a time can really communicate. So, the more hops you have, the more uh, kind of, like I said, latency and kind of bandwidth limitations you're introducing into your environment. So that does impact the your customer's experience. It impacts how well clients are perceiving the network's performing. All of that is comes into play with mesh. Um, the other big thing is power. Power can be an issue with outdoor APs. So cable runs can be kind of outside the scope of a typical PoE deployment from a switch. So you have to think about how are you powering your devices, um, and how is that going to impact having a not only a quality amount of power, but a reliable power source. So you're not introducing coverage holes if an access point goes offline, those kind of things. So some just tips real quickly to kind of overcome some of those design challenges. I like to, this is one of the few instances that I actually do like to statically assign power to access points outdoors. This allows you to kind of have a better control over the size of your coverage cells. So you're preventing kind of that signal propagation issue we talked about. So if you statically assign your power, you know how far that signal is going to propagate from your access point, from your antennas. Those security concerns, make sure you're using some type of intrusion prevention mechanism. So a lot of these wireless vendors these days have whips built in. So use what you already have, right? So use your tools that come or come with your hardware and software that you've already purchased. The other big thing is use certificates. Use 802.1x to authenticate your devices, not only in terms of the clients connecting to your APs, but also um, the access points, the hardware authenticating to your wired network. So use the mechanisms in place that can kind of help prevent unknown or untrusted devices from physically connecting to your network, those kind of things. The last thing, and probably the most important thing, is site surveys. Your network is only as good as the design. So making sure that you're following best practices for design, and you're not only doing the predictive survey before, so to help with that planning phase, but you're also going on site and you're doing physical surveys. So that's going to save you hours of rework later on. You're going to know what the environment is looks like. You're going to know kind of interference that's there present in the environment, kind of not only building interferes, but also is it just an open courtyard with a bunch of free space and nothing kind of blocking the area? Are there trees that you weren't aware of? Those kind of things. You're not going to know until you physically are on site and can see what the environment looks like. So point to point, again, this is one type of wireless network. I have experience with this in the past, multiple different varieties of point to point networks. So the main thing that I think of when I think of point to point is connecting two different locations or buildings together without the need for running expensive cables. So you don't have to worry about running leased lines. You're not running who knows how far of the cable run you'll need in some instances. So you don't worry about the physical cabling. You'll have your device typically on top of a building or very high up that is connecting to the corresponding device at the other location. This is a private link, so you're not sharing the media with the lease line. It's significantly cheaper than running cable miles or kilometers. There's a lot of less legal restrictions. A lot of these devices are using unlicensed spectrum, so you don't have to worry about licensing and getting the government agencies involved in terms of giving you a frequency that you're allowed to use. A lot of these are already unlicensed. Throughput these days are plenty fast. You can get over 10 gigabits or more with these kind of point-to-point networks, and range is quite far. Yeah, I've done a deployment where it's I think 30 miles away is the furthest that I've ever done. But it goes over 100 kilometers as well. And of course, every environment is different. So this is actually a photo of an installation I did at a previous job with using ubiquity air fibers. I worked for a healthcare company that had some outpatient clinics in a downtown area, and connecting kind of our main office to a remote clinic that was, I don't know, 45-minute drive away from the downtown area, and we connected it via a ubiquity air fiber. So being able to connect our office back without having to pay for a fiber run or using um, uh, like an ISP in the area and using a VPN tunnel back. It was all our own equipment, so we kind of uh, managed that whole installation from kind of start to finish. But I've also had some other experience with uh, when I was in a university, we had a installation on top of our academic building that went, I want to say it was like 50 miles to like an outdoor recreation area that we connected back to the university so we could monitor cameras there to watch like wildlife and other things too. So that was also a wireless link back. Um, Another option is point to multipoint. So if you're familiar with like typical networking, this is kind of that star design or a spoke and hub type topology where you have a central location and then you have remote locations connecting back to that one central location. Typically, this is done with like your wireless ISPs, or if you're doing some type of video surveillance application type deployment. Um, all of that is done kind of in this point to multipoint wireless network design. So you'll have a central base station that's mounted quite high, and then they'll reach out to those kind of base stations or those um, uh, kind of other nodes. Here, again, line of sight is very vital to have reliable performance. So you can kind of think about this in terms of like a wireless switch, is kind of how I think about it. So you'll have your central location as a switch, and then your cabling or the wireless link is going out to all the other nodes. So the benefit here is that you're getting kind of a centralized management or a centralized location. Um, you're reducing kind of that complexity in terms of your backhaul. Um, but the main thing here is that interference management. So you want to be aware of where your interferers are, and then kind of plan accordingly. But the big thing you're getting is that flexibility. You're getting a mixed deployment. You can add in more point-to-point bridges along the way, so you have flexibility to kind of quickly expand that you don't always have when you're talking about kind of running cable and wired side performance, that kind of thing. And then the mesh side, so point to multipoint, specifically on the mesh networks. This is very common if you have a very large area to cover. So the way these are kind of deployed, you have two different types of APs. You'll have a what's called a root AP and then a node AP. So your root AP is the one that's has that physical backhaul connection back to your network. So it's physically cabled back to your environment. And then your node AP is typically connecting back to those root APs or other access points over a wireless link, and that's its backhaul. Some things here, you want to minimize the hop count with the mesh network. Um, the other thing is you want to maximize the signal strength that you're using for your backhaul. So if you have an access point that's connecting back to another AP as its backhaul, you want to have the best signal strength you possibly can there, so you have a strong connection. You also want to group your node APs around. Oops, sorry. You want to group your node APs around that root AP. So you want to plan accordingly so you can try to limit the hops to only one. Because like I said previously, each hop that you're adding is increasing latency, it's increasing overhead, and it lowers the effective throughput essentially. I like to say only use this as a last resort. I'm not a big fan of mesh networks, but they have their place. So it makes sure that your requirements are very defined. You know, kind of application specific requirements as well. So if you have a very low latency application that you're supporting, or you have a real time monitoring application, that kind of thing, that is very susceptible to latency or very susceptible to fluctuations. Maybe a mesh network isn't what you're looking for, but there are in instances where mesh networks are the best network for you to utilize. So my biggest experience with a mesh network, previously I also worked for a utility company, and we had a fully deployed mesh network at a natural gas plant that we kind of supported. So utilizing um, the environment that we had, it was the best way for us to get um, kind of full coverage of the whole facility out, because it's a kind of a mix of between indoor and outdoor uh, kind of environment where people were coming in and out of the facility, but still needed to maintain connection. So they used, I think they used iPads. It was either iPads or they used kind of a rugged kind of touchscreen laptop. But they were using it mostly for monitoring. It wasn't necessarily real time monitoring. So latency wasn't a big deal for them in terms of the application, but they were using it for like checking pipes and doing their maintenance at the facility. So having that kind of outdoor deployment for them made their life easier. Um, some issues that we kind of run into specifically with outdoor deployments. A lot of these are RF related. So you'll notice that sometimes clients are disconnecting quite often. You'll see some slowness for some clients. A lot of that is due to installation. So if you're installing your APs or your antennas kind of near metal objects, or if they're fully shielded by a metal object, sometimes I've even seen installers install the AP and the antenna in a metal enclosure because they were thinking, oh, well, this metal enclosure will surely protect this device. It sure it protected it in some ways, but metal just completely destroys the RF. So a lot of these outdoor issues or these issues that are kind of prevalent in an outdoor deployment are due to installation issues, whether it's lack of grounding, it's physically installed wrong. A lot of these things are also causing some of those problems. So you'll have coverage holes where in your design you're expecting this section of this area to be fully covered, and once the installation happens, you're missing some coverage here. So this is where those physical on-site site surveys are very important as well. And then in terms of mounting APs, so you always want to make sure that you're using the proper mounting bracket. Um, you don't really want to improvise necessarily on the mounting bracket. You can improvise in other ways, but a lot of these vendors these days are giving you plenty of options in terms of how to mount their APs, especially if they're outdoor rated already. So some of the more common ones are brackets that you can attach to a wall, so it's high up on an outdoor wall, or you can attach the bracket with a clamp on an existing pole in the environment. So there are some mounting brackets for that. Um, One thing to note, if your device or your access point is not IP rated for outdoor use, you do want to make sure that you're installing it in some type of like NEMA enclosure. So the other thing to note too is install your APs near your clients. Optimally, your clients or the devices in the area will have line of sight to the access points. That just makes things a lot easier. Um, the other thing to note too is whenever you're outdoors, vertical space is a little different than what would be in an indoor environment. So I typically recommend not to install client-facing access points, so the APs that clients will actually connect to. Don't install those more than 40 feet in the air. Like your backhauls or like your wireless bridges, those point-to-point networks we were talking about, or like your root APs, those can be higher. So if that is how you get kind of line of sight to the rest of your network, uh, yeah, install those higher than 40 feet. But the ones serving clients, kind of keep them 40 feet or under. The other thing too that I don't think a lot of people necessarily think about is orientate your access point so you can see the operating LEDs from the ground. So mount it in a way that you don't have to get on a ladder to visibly see status LEDs if you're on site troubleshooting an issue. It just makes everyone's life easier if you can just look up and see some status LEDs and quickly see kind of what is this access point doing? Is it serving clients correctly? Is it kind of not joining the controller? Those kind of things. It's not something that when I started that I necessarily thought about, but it does make everybody's life a lot easier if you make sure that you're letting the installer, if someone else is doing it, make sure that you let them know, hey, I need to be able to see these LEDs from the ground. Those kind of things. So in terms of like mounting options, there's a lot of things these days. Whether it's like I said, the wall itself, so there's some enclosures like here over here, where you can have an enclosure on a wall, and then you're installing the AP and or antenna if it has an external antenna within the enclosure, and then you can kind of close it up and protect it that way. You can attach access points to existing light poles. There are enclosures like within the ground, like this here. Looks like just a regular bollard. It actually is holding an AP and the antenna all within an enclosed enclosure. In terms of selecting an enclosure that works for you, you obviously want something that you can physically protect your devices, so something that you can lock and you don't have to worry about people um, kind of accessing your equipment. Weather protection is a big thing. You want to make sure that your devices are protected from the UV rays. You want to make sure it's protected from moisture, heat, cold, all those things. You want to make sure that the operating ambient temperature of your whatever your device is rated for, the enclosure can maintain those temperatures for your devices. Aesthetics are a big thing too. I don't think that typically a lot of wireless designers are thinking about aesthetics, but the people who are paying for it, the people who have the budget, the people paying you to install this, aesthetics are big for them. They don't want some device that kind of ruins the view of their their paying customers or ruins the view of certain things. You want to a lot of these installers typically will want to hide devices, make it look like it's not there. those kind of things. The other thing to note too is cost. So when you're deploying an outdoor network, typically the costs are much higher than a similar deployment of same number of APs inside. Inside's a lot more standard. You have just kind of a standard price in terms of getting cabling ran and then mounting. But outdoor things can get a little more trickier in terms of if you do have to run cable somewhere in terms of getting conduit poured or um, finding power. We'll talk about that a little later as well. But there are some complications with outdoor deployments that can quickly raise costs. So here's some examples of kind of those Nemo boxes. So you can see here some of these have intake and exhaust fans, some filters in place. A lot of these have built-in power as well, so you'll have power ran to the boxes, and then you'll plug in your devices within the box. Everything is contained within that box as well. So in terms of selecting antennas, so this is critical, especially in outdoor deployments. So you really want to look at radiation patterns to determine what antenna is going to be right for you. You want to avoid obstructions, so you don't want to install near metal objects or obstructions. Um, and poor or improper antenna setup is usually one of the more common causes of poor performance. So here on the left here shows you kind of a typical radiation pattern of an omnidirectional antenna, and then these two are more directional antennas. So the one here in the middle is more of a patch antenna where it's still directional, but you have a very wide area that you're covering. And then this is typically kind of um, a high gain panel antenna to where it's very focused, so you can get quite further distance away in terms of signal, but it's a very narrow coverage kind of area as well. So knowing what your requirements are and what antenna works for your environment is kind of critical in selecting what hardware you're choosing. And then in terms of selecting or supplying power, so this is always kind of a tricky thing outdoors typically. You need to verify your power requirements. So whatever your access points have selected, uh, you will need to make sure that if you're supplying power from the switch, you have enough overhead to accommodate the power requirements. If you are using a power injector, one thing to note, most of these are not IP rated, so they're not designed to just be deployed outside without any protection. So kind of think about that when you're deploying APs. Are you using AC power, DC power on your access point? So you have some options there. Um, but a lot of these need to be deployed inside some type of enclosure. Um, this photo here, excuse me, is what that bollard looks like on the inside. So you'll just install everything here, and then you'll put the bollard kind of plastic piece over top of it, so it looks like just a regular bollard. Um, Another thing too, in terms of providing power, if you're installing on light poles, this is what we did for the natural gas plant I was talking about earlier. So there were light poles around the whole facility, and we used taps to utilize the power that was being sent to power the light bulb. One thing to note about those is a lot of your light poles have what's called a solar eye on the pole itself, and that is what's controlling the power to the light bulb. Um, Depending on where you tap into the power, your AP could just be turned off. So during the day, the lights are not needed, so they turn off the power to the light bulb to save costs and save energy, and your access point could also be turned off. To get around that, there's some battery banks that you can kind of use when you deploy. So when the power is on, they're charging the battery, and when the power gets cut off, you're now running off the battery as opposed to the light pole itself. So there are some things that you can do to kind of help with power, but there are some caveats as well to keep in mind. In terms of deployment as well, grounding is very important. So it not only kind of helps kind of protect your investment, protect your equipment, but it also kind of makes sure that your devices are lasting as long as the intended use for them. Devices that are not properly grounded um, can cause some major issues, especially your downstream devices. So if they're connected to your switches, if they're not properly grounded, they can transfer that excess energy over the wire back to your indoor network or your other kind of upstream devices that can cause equipment failures. Um, they can cause a switch port to just stop working altogether. Worst case, they can cause an entire switch to fail. There are some benefits though, typically outdoors. So if you're mounting on a pole, there's usually an existing ground wire also on that pole. So you can just tap in right there and you don't have to run the new ground wire all the way down to the earth. So there are some kind of benefits to kind of using what's already deployed in the environment for mounting your APs. Um, Basically, you're just preventing static buildup, which can just damage equipment. So you're static buildup on access points in particular can cause some quite odd behavior. They can reduce your transmit power. So instead of just a full failure, they can just make it to where your APs are not transmitting at their optimal power anymore. And the receive sensitivity on your access point can also be compromised. Worst case, they completely cause a hardware failure. The other thing to note too is corrosion. So make sure you're using some type of anti-corrosion compound when you're connecting cabling, so you don't have corrosion buildup on your deployments. A few other things to think about too. So in that static buildup, you need to worry about lightning when you're mounting outdoors. One, you want to make sure that you're checking the requirements from your AP manufacturer. A lot of these APs that are outdoor rated that have indoor or in internal antennas will have internal circuitry built in as well to kind of help prevent or protect from lightning strikes. But those antennas that are external or directly attached via a cable, those are where you can attract lightning. So you want to make sure that you're grounding every single cable with a lightning arrestor. The other thing is that typically that is a requirement for whatever regulations you have in your installation. So it's a code requirement to also use lightning arrestors. The other thing too is insurance. So if you have a lightning strike that causes damage, if you want insurance to kind of um, pay you in your claim. If you didn't have a lightning arrestor, they will usually not pay you back in your claim because of a proper installation. So keep that in mind as well. And then water, so moisture. Anything not IP rated, again, put it in an EMA enclosure. You want to cap all your unused ports as well in your enclosure. So seal all of them. Seal them with metal caps. I don't typically like plastic caps, especially outdoors. Plastics can fail pretty easily, and then now you have an opening into your enclosure, and water moisture buildup can happen. Use the included rubber gaskets as well. That's very vital for the cabling that's going into the enclosure or into wherever you have it your device is mounted. Typically, you're running an Ethernet connection out of the enclosure somewhere else, or you have some other type of connection coming into the enclosure. Make sure you're using those rubber gaskets for those connections. The other thing to remember too is you want your Ethernet connections running downward. You don't want your cable coming into the top of the box. You want it to go into from the bottom. You use gravity to help you with your moisture buildup. Don't fight against gravity trying to deploy cable. So instead of running it 3 extra feet, you have a shorter cable run. Get the cable length that's required. Go in from the bottom to kind of help you with keeping the moisture out of your equipment. The other thing is drip loops. Make sure you're utilizing drip loops. Here's an example here. Again, use gravity to help. Any water that's coming down this cable will reach this bottom and then drop right off. So use use gravity to help solve some of these problems. You also want to use shielded cables. So not only to keep moisture out, but that helps shield the electrical interference coming out of the cable that can attract lightning, those kind of things. So water will just kill APs. Water is one of the biggest kind of issues that you're going to have to deal with in terms of an outdoor deployment. So make sure that you're addressing those concerns before you start your installation. So kind of a quick summary here. Site surveys. They're essential. They're probably the most important piece to getting a successful outdoor deployment. In my opinion, they're the most important piece of Wi-Fi in general. Like I said previously, in my opinion, your network is only as good as what it was designed for. So making sure that it's properly designed from the start kind of helps alleviate some of those kind of issues that will arise later on. Complex networks in particular, the more complex the network is, the more issues you probably will have. Um, Wireless links in particular, they will create latency and lower throughput, but as long as you've planned ahead and you are aware of that, you're probably are fine there in terms of what your clients will experience when they're on the network and how their devices will behave. And again, proper install is kind of how you alleviate and prevent some of those client specific issues. So just kind of taking a disciplined approach and following best practices, following proper design guidelines is how you kind of overcome some of these challenges and ensure that you have a stable and successful wireless network outdoors. All right, then we'll go to Q&A.
All right, Jack, great job, man. A couple questions came through. Anders was lighting up the chat. Some funny dad jokes in there. What I'll call dad jokes. The guy needs some sunlight. It's dark all day where he is. Okay, couple questions. Let me start with Faisal. He said, does the wall mounting box interfere with the signal?
If it does, it's very minimal. So typically they're made with plastics that or materials that do not introduce a lot of attenuation. But again, you'll need to find out what mounting options are right for you, and then you can do your own calculation. So again, with those site surveys that we talked about, you can calculate what attenuation those boxes are causing in terms of your signal, and then plan accordingly. But it's not a whole lot in terms of signal that it's interfering with. Just make sure you're not using metal.
There you go. And we've got two here from Anders. Any 802.11 based point-to-point links done on 6 gigahertz?
Yeah, I mean there are some. Typically, you'll see that with a lot of mesh deployments, where you'll have um, like a backhaul that's on a dedicated 6 gig uh, kind of frequency. that helps alleviate some of those latency, and throughput issues if you use like a dedicated band. Typically, a lot of these new kind of mesh deployments that's how they kind of operate. But in terms of point to point as well, there are devices that are um, that you can use dedicated bands or kind of the 6 gig. I've used 5 gig in the past as well, where I've just used a typical access point that wasn't serving clients, and that's how I was doing a point-to-point link. So yeah, you can definitely do that with the 802.11 standard.
All right. Thank you, Jack. Thanks for the question, Anders. Two more, Eric, then we're going to throw it over to you. We're coming up on time here. So, if you need to mount an AP with an internal Omni midspan on a metal pole, how far away, bracket length, from the pole should the AP be? I'm trying to visualize that in my mind. If you're having trouble with
Um,
that.
that's actually a good question. I've typically done deployments on light poles to where I'm utilizing the pole itself. Yeah, like what Anders said in the chat, it depends. That's kind of the answer to almost all design questions. But yeah, it really depends. Typically, I've done light pole installations where I'm mounting it uh, kind of from that. So if you're imagining a pole here and then the light is hanging from this side. So I'm away from the pole and I'm mounting my AP over here near the light portion. So I'm probably at least 3 feet or like 1 meter away. But it really depends on kind of the environment. That's where once you've physically installed, it's very vital to have those on-site site surveys. So if you need to make adjustments, you can.
Thank you, Jack. That was from anonymous attendee, one of our shy attendees. The next one, the last one here, going back to Anders, how many node APs to one root AP? Does it make sense to add another root AP to share the load?
I don't know if there's a hard set rule for like you need this X amount of root APs to node APs. I typically like to minimize the hop count first. So if everything can communicate back to that one node AP, as long as that node AP is not serving clients, then you're okay. But obviously, you don't want to have like 100 access points connecting back to one root AP. So it's a fine balance, and I think knowing what your kind of most important, least capable device is in terms of like design is very important, and knowing the applications that are being ran in the environment, kind of what latency they require, what bandwidth they require, those application requirements can then be used. I'm sure there are like online calculators you can use to help you kind of determine what overhead you're adding to your environment based off of the number of hops or the dense the mesh deployment is. So again, to use your answer to your own question, it depends. So
Mesh is the root of all evil, he says.
I agree with that.
He is quick, that guy. Anders, hopefully we can meet up in San Diego in a few weeks at Cisco Live. Eric Camuli, the floor is yours if you are ready for some 7 minutes with seven signal to wrap this up.
Hey,
Bring us home.
how is everybody out there? Nice to see you again. All right, so if I have the ability to share, I'm going to do that.
Oh,
And you know, guys, it's that time. It's that time for 7 minutes with Seven Signal, where we take a small feature inside Seven Signal, unpack it, and show you how it can have huge value. Yeah, so here we go. And I'm going to hit share, and I'm going to show you my screen. And hit the share button because I always forget to do that in Zoom. And give me the thumbs up if you can see my screen. Please. Pretty
Yep.
please.
got it.
All right. Okay, guys, here we go. We're inside Seven Signal here. And we're going to talk about in the spirit of Cisco Live coming around the corner, we're going to talk about the new integration between Meraki and 7-Signal. Pretty cool. Pretty cool. And the integration that we're talking about here is with regards to synchronization of access points. All right, this is actually a feature that a lot of our customers have begged us for over the years. Is there any way that, you know, the access points that are in this system can kind of match up with the access points in that system? And if we've already got, sometimes there are two sets of access points. I've got Arubas. I don't want to overwrite the Aruba access points, but I've got these Meraki access points where, you know, how can we sync up the system? So I'm going to show you how we do that with our new 7-Signal Meraki tool, an integration that we've created using the Meraki API with the 7-Signal API. It's pretty hot. All right, so here we're looking at 7-Signal right here on our screen. And as you can see here, we have these locations. These are different locations. When we click into locations, we can see performance information and data for devices on which 7-Signal is running. Let's go to the next tab. If you're not aware, the way that 7-Signal does locations is by mapping access points to the location name. And the location name could be whatever you want. The location name could be a floor, a building, a wing, a city, a state, whatever you want it to be. But here are the names of the access points right here. And usually when you've named an access point, you've given it a name that is quite descriptive. And so therefore, it is ultra important that we have the names of access points in 7-Signal, because when a 7-Signal device that's activated with our agent actually hits that access point, we pretty much know where it is in space, which is pretty cool, All right, so let's move along here. We're going to go into our little Meraki playground. Okay, and that's where we are right here. I am showing you an example of where, okay, we already have some Meraki APs that are in place. But you know what? I want to sync the two systems. Our Meraki system in the cloud, we want to get those access points and those access point names into 7-Signal without erasing, or by doing that sync, copying over what I already have here in place. How do I do that? So let's go to our new tool here. Here it is right here. What you have to do is you have to have Python on your computer. So I have a Python installed, and this whole thing is a little Python script. Okay, it's a repo. You just suck down the repo and you can install it, install the requirements. If you're a Python user, you know what I'm talking about. And then from the command prompt here, you know, because I'm on my Windows machine, you can actually then run the little 7S Meraki CLI tool. And it's super simple. There are really just a couple of very simple options, okay? And what we're talking about here is sync agents, if you can see that there. So as you know, our little agent goes on your PCs, it goes on your MacBooks, it goes on your Android devices. Sync sensors. Okay, so as you know, we have a whole additional part to our platform, which are our sensors. Okay, and then here, so we can actually sync between the two systems. We can sync where we overwrite everything in 7-Signal, or we can sync where we just add or apply what's new and we don't overwrite what's in there. And then there's something here called export CSV, which is just another way to get the data out of Meraki and into a CSV file, which is then ready or tailored to be then imported into 7-Signal. Let me show you how this works. Okay, it's so simple. So down here, I'm already in the right place. And what I'm going to do is just from the command line here, we're not going to do help. We're going to do this one right here. 7S Meraki is the command. Sync-agents -- no deletes. That's the flag. With that flag, okay, what that means is that I'm going to take all of the access points that are in Meraki and bring them into 7-Signal without overwriting my existing access points. And guys, this is just for Meraki. We plan on doing this for all of the major players out there. Integration between systems being absolutely critical. Let's run this sucker and see what happens. Here we go. Initiating, you can see the authentication, super easy. Okay, here we go. So what it basically did is it said, hey, I've identified that there are 22 new access points that I'm going to bring into the system here. Well, let's take a look and see what happened. So let's refresh the page. Bada boom, there they are. Okay, and here they all are. Here they all are. Okay, and I can then move them into locations. The next thing that we're going to do is we're actually going to improve the integration so that we can bring in the locations from Meraki as well. Okay, let's just kind of move these into a location, and that's how it works. And now I've got things in here. Now, let's just play around a little bit here. What if I were to delete some of these things? Oh, wow, I don't know how they got deleted or whatever. I'm just going to show you how we do a sync. So let's delete these guys. Yes, I'm deleting them. Oh, I've got 13 plus 4 plus 7 now. Let's run our little sync again just so I can show you what it looks like. Let's go here and let's do this. Boom. Okay. And what's it going to do? What's it going to do? It's going to identify that there are 5 new access points because I deleted a bunch of them. And so now it's like, whoa, whoa, whoa. I thought we were supposed to be in sync here. So it's just an example of how the sync works. Let's refresh the page again. And there you go. We're back up to 18. And the access points that were deleted are now back. Why? Because I'm initiating the sync. So that's pretty cool. That's what I wanted to share with you guys today. It wouldn't be a 7 minutes with a signal if I didn't just show you one more thing with regards to Iris. Iris is the new AI built into 7 Signal, your Wi-Fi engineer in a box that is basically going to be also showcased at 7 Signal. When we detect that there's an issue here, Iris, who's our little bot right here, is going to light up. What makes Iris different and unique is that she is actually taking the information on the page. Okay, and then packaging it up in the form of like a JSON file. It's going into our little engine, and she's analyzing the information. And as she's analyzing it, she's determining, aha, I see something going on here. What could it possibly be? I think it's these things. And then not only that, but it's going to offer some recommendations. Check it out over here on the right. So here's the issue. Okay, and we're talking about the factors. And again, it's taking the information on the screen. This is not a generic recommendation like what we had provided previously, but actually we've taken all of our 7 Signal knowledge over the years and we've poured it into the system in order to come up with the best solution. And you know what? It's just going to get smarter and smarter over time, as you guys know, because at the bottom here, after the recommended fixes, there is the ability to provide feedback. Okay, and if it's not a good response, you can just indicate what it was right here, send it into Iris, and then Iris will learn. She'll get smarter for the next time. So there you have it, guys. There you have it. That's what I wanted to share with you today. And we hope to see you at Cisco Live. If you're going to be out in San Diego, please, by all means, let Don know. And remember, while you and me, we can't see or hear Wi-Fi, but 7 Signal can. Thanks for joining us, everybody. Back to you, Don.
All right. Thanks, Eric. Thanks for joining us, everybody. We'll see you next time. Yes, please look us up at Cisco Live or shoot me an email, and I'll get you the info to some happy hours and get you guys connected with the rest of the team here. Cheers, everybody.